Okay. Oh, that's not the right window.
Testing. Okay, it's muted.
Is the focus correct? I think it is. Very nice.
How far is the sting behind me? A little bit in my pocket. Quick selfie. We don't hit the microphone. For our parents. Sure. Right. Nice.
All right. This will be interesting. Honestly, feels really weird. Like I would never imagined standing here when I was taking like classes.
Yeah.
I think the right hand mic and then click for this and that's fine. Dual wielding equipment. How loud is the mic here? How loud is the mic here? Okay, seems to be full volume, so that is good. Oh. By the way, the guy sitting over there, he's not from Tudor.
Which one?
There in the middle.
Oh, the guy who gave it the thumbs up.
Yeah.
Where do you
He's a
know him
friend of
from?
mine. He's a friend of mine. I let him know that I was giving this. He was like, "Can I help you?" Meet up. Basically, he studied called like writing laws, and then he decided to pivot to comp sci for his master. So now he's doing a master in comp sci, but he doesn't know that much. Oh wow, we actually got
Hey, 14.
Directly on the same dollar.
Okay, so I need you to spread out through the audience,
yeah.
and at the right moment,
You have horrible
you'll know
questions.
you get a cheer, like stand up and like scream.
We really should spread out, otherwise they're.
Yeah, get a plan. And then this hand signal means that you get a laugh, like really, really loud.
You don't have a giant, please laugh.
I have just like frowny smileys somewhere, so you can brew there. That's about our project being C++20.
You couldn't convince better to update to
Well,
23 or whatever.
for the private version that people will be working on, they are allowed to do whatever they want because it's not graded and independent anymore.
Lucas and Joris might join during the day. Lucas and Joris might join during the day.
Nice.
All right, but the second part is the least useful part for the group, I think. The first part is the actual useful part for the group.
Yeah, but the second part's gonna be the funniest part because there's pitfalls.
True. That's just going to be talking about the CP project and then a little bit of pitfalls with Jackson hating C++. The first part is like actual C++.
I mean, I don't expect much.
Because it is the same as what you gave during the individual lunch.
That was a very rough draft. So, sort of, but hopefully it's significantly better now. That was an unpracticed draft I made the day before and that was not ready.
Can the people online hear us?
There's no people online, it's just Jackson and me using it, so I can check this out. I can Alt tab to the screen share, and then Jackson can share his screen. Wait, let me.
Wait, this is going over TV?
No, only Jackson's screen share will. That is so that we can record it, and then later on people can watch the recording if they want. In case I don't even know if we posted, right?
It won't be posted because if there is an actual recording, that would there are surfaces such that it is actually automatically recorded.
Yes, but
So
I
you don't have to
want to. I don't think this one is recording us now.
No, because the course
We didn't use Collegiana. I just want to have a recording in case next year they decide, hey Jackson, you're still here. Do you want to give the lecture again? Well, my contract is gone by then.
It's gonna happen. I'll rope you back in.
No,
I think we should ask
the
Mark
baby
next
trip.
year.
Yeah,
Actually, though.
give the Blender lecture and plus lecture.
All right. See you. Thanks. You got 5 more minutes.
If you want, feel free.
Yeah, you guys can take the lounge.
We are not going to talk about it at all. People are going to wonder who are these people sitting there. We are like, we don't know.
We should just invite a few students to sit at the front if they want. Before we start presenting, do you mind if I ask how many people know C++ already?
That was what I was
Oh, okay,
gonna
yeah.
do already, actually.
Show of hands.
Yeah.
Yeah, that's perfect.
I'm going to be asking multiple show of hands questions anyways, because it's more efficient than asking one person. It's more fun to see what the entire hall thinks, and it's less of commitment, kind of. How do you say that?
Yeah. Yeah, you also more participation.
Yeah, the people will be less afraid to do a show of hands compared
Uh-huh.
to being the one to answer.
Uh-huh.
So that's why I always prefer it. Oh. What time do we actually start?
45.
Do we actually start 45 or do we wait until like 48 or 50 or something?
Maybe like 47, 48. I wouldn't wait too
You should time me, by the way.
Yeah.
If I'm taking too much time, then just like put a timer there or just put a stopwatch. Not a
Yeah, I'll do a stopwatch, not a timer.
All right, that's good. Then I know past 20 minutes, you can just give me a signal or whatever. 20 minutes is basically the cut off
Uh-huh.
point where I think it's going over too long.
Mhm.
But it should be fine. I think you can make it in a few minutes.
Uh-huh. We can also refresh the timer there. Please have to remember to do it.
Oh, okay, but it's small.
Mm-hmm.
I don't like how small it is.
Yeah. Plus, this one has the scary fast numbers. This one's got the high
Yeah, that's
pressure.
kind
fast
of
numbers.
annoying.
Well, after it gets to a minute, it'll go away,
Okay.
I think.
I also gotta remember to stand here, because if I don't, then the camera here will not see me. Like,
Mhm.
if I stand here, you get this.
Uh-huh.
I can turn it though. Wait, maybe it's better if I rotate it a bit.
I'm not going to make much effort to be in frame.
That is fine. But... Yes. The
So
center
this
is
is where you have to pick an audience member who will make eye contact the whole time.
yes.
You can present to your friend.
Yeah, I'm just going to pick out any. You there, answer my question. You should remind me to share my screen again after we switch back by then.
Oh, yeah. We'll see it
Why-
on there as well.
Hmm?
You'll see it on there, so it'll be more obvious too.
No, that is just my screen.
Yeah, so you'll know you're not sharing.
I don't. Oh well, I don't see the red. Okay, the red border, I guess, but the red border is my only hint because once I alt tab back to PowerPoint, it's going to look the same.
Ah, I
Right? So I don't actually see it other than the red border. Uh-huh.
You see the red border as well.
Yeah, that is the trade-off. I think I'll live with that. Uh-huh.
Okay, we'll give it like 3 more minutes.
Yeah, that's what I mean. Like people are still
Yeah.
entering always.
Uh, or we could take this moment to be one of those professors that locks the doors.
Oh god, that's not the first impression I want to have for my first lecture. Our first lecture. People are so spread out though. Holy shit.
There's one person up in the very top corner.
Yeah.
Their coat.
Is the next lecture next week for the actual PG content?
I think so. I don't know if we should say. We can just say the next lecture.
Have you seen the Brightspace page if they actually announced that today would be about C++ or no?
I don't know if I'm on that Brightspace.
Yeah, I don't know either. I haven't checked Brightspace. I wouldn't know, but it's mostly just to know people's expectations for today's lecture.
I guess check Brightspace is always good advice.
Also for us.
Yeah.
We should have done that. Yes, so that's why I said should we start at 50?
Maybe 50.
Because there's still a lot of decline from it, so yeah. You just check the doors. Like if we start now, the problem is that every second there will still be some person entering the room.
But it's such a big room that we won't hear it so much. Right.
That is true. But it will cause a lot of chaos. So I think we start in 1.5 minutes.
Yeah.
Then we just start talking.
Break a leg. I think it'll be good. I think because this is sort of an optional lecture, we'll get the students who are more interested as well.
Was it optional? Most people know that it's optional.
All lectures are optional in 2020.
Yeah, fair. Okay, 1 minute and we should really start. We set the timer now. Okay. This is what I mean.
What?
I look at
Okay.
how many people are still entering. I have to pick a point where we actually start, right? So that's the.
Works. Yeah, whenever you feel it.
What is Yeah. Hey, everyone. And everyone that's still walking around, please find a seat so that we can get started as soon as possible. Um, I hope you're all here for the introduction to C++ and not for the first concept of computer graphics, because not today. Was there anything about this on Brightspace by any chance? Okay. So today we will not be going over computer graphics yet, but we will be going over a topic that's very much related for you guys. C++, something that I assume most of you have not yet worked with. Can we get a raise of hands for people who already used C++ before? Oh,
Oh, wow.
do they teach it in another course now? Oh, okay. So everyone's here for an introduction to C++, but have already used C++. Oh, okay. That's good. Then we can skip over something. All right. So who are we? We are not the professors that will be teaching most of the computer graphics course. Instead, we are PhD candidates here in the computer graphics group, and we've been asked to give this introduction lecture because we were told that most people here didn't have much C++ experience yet. I'm Amir. I am working mostly in C# and Unity, but I know enough about C++ to give this lecture. I'm working on virtual reality mostly, and I fell in your seat about 7 years ago when I was taking this course during my bachelor year. So it's great to actually get the chance to be on the other side for once. And next to me, joining me is Jackson.
Hi, everyone. I'm Jackson. I'm from the US. I studied computer engineering and then came to the Netherlands for a master's in computer engineering. But now I'm working on machine learning. So it's funny because I've switched from the US to the Netherlands, and I've switched from C++ to Python. I'm a lot more happy about the first decision. But I got started on Arduino, like I'd imagine a lot of you did. So I've been writing C++ for, I don't know, a decade now. And I was brought on to help with this because I love the language, despite its flaws, which I guess makes me the right person for the job.
Thank you for the introduction. So when I sat in your seat about 7 years ago, we had this professor right here presenting computer graphics and C++ to us. Fortunately, he can't be here for us this quarter, but we are trying to fill his shoes, and trust me, they are massive shoes, these are like 3 meters tall or something. If anything we explain is confusing, please just raise your hand. We'll try to answer it in real time, and maybe even script it in real time. So do ask questions. Now, what will we be going over today? First of all, we will go over the basics of C++ and why it's actually good for computer graphics. A little bit about the more advanced C++ topics. Then after the break, we will go over the project that you will get for the CG course that you get to work on in your own time. A little bit about the file structure you should be using or how to create your own project if you would ever want to. Some object-oriented programming, which is slightly different than C++, and a lot of common mistakes. First question you might be asking is, okay, well, you can do graphic programming in Java or C# or any other language. Why do we use C++ for this course? And there are good reasons to not use C++, so I get the question. If you look for C++ online, the first thing you will find is to stop doing it, or that it's dangerous, according to AI. But we want to argue that C++ is still a very useful tool to teach because most production games actually do run on C++. So if you ever want to work on
games or game rendering engines, you need to know this language. Not just games, but also movies. So most movies are rendered using a graphics engine built in C++. It's also the industry standard for a lot of tools related to graphics. For example, Unreal Engine is all C++. If you've ever used Blender before, it's also running on C++ under the hood. Maybe you don't need to use C++, but a colleague of ours actually went to Blender recently, and then the C++ experience was very useful to get hired. And last, there's at this point, pretty old graphics API already, Vulkan, which is also C and C++ first. So if you want to use Vulkan in Java or in C#, which I've tried, it's very painful. Now, why is it the industry standard? Okay, so let's take as an example, Avatar, Wave Water. I think it's the second part. There was a quote from this in an interview recently where the developers behind the scenes talked about the performance cost of rendering a single frame for this movie. And they claimed that it took about 8,000 thread hours. If you need to render an entire movie with a performance cost like this, then of course you want to squeeze out every last 10, 20, 30%. So Python might not be an option. Well, that sounds great. But how do you actually get started with C++? And I think the best way to show this is also a slightly risky way. We're going to have Jackson here on the side be tortured by having a real world C++ implementation in real time. If you want to follow along, I have a QR code you can scan on your phone or a link you can enter on your PC. Don't worry, they point to the same address. So you can actually try to edit stuff in real time as well if you want. Let's switch screens now, I guess.
Yeah, let's
Oh,
leave
wait,
that on for a moment. Go back to the QR code.
Sure.
I heard a gasp.
Oh.
Everyone's got to do the awkward dance of scanning the QR code on your phone and then messaging it to yourself so you can open it on your laptop. So we couldn't think of a better way to do this.
You first show the screenshot, probably.
After they use the QR code.
Yeah, that's good.
All right. Has it been a good amount of time? Yeah.
Everyone that wanted to take a photo could take a photo of the QR code or scan it immediately. Okay.
All right. So I'll
Then-
share my screen.
Wait. Let's first go over there. Okay. So the first thing you will see when you're opening this link is that just getting a hello world, or in this case, an x equals something print to the output is not that difficult. So on top, you have an include statement, which is very similar to Java's import. Then you have a main function that gets called when the application starts. So the slight difference from Java is, of course, that this one is not inside of a class. It's just a freestanding function with an integer return type. Then you have the print line function that will print something to the output, where you can place an argument inside by having first part be a constant string with curly braces. And then the second argument will be your variable that you're trying to print. And this is pretty similar to how Java works. So if we just directly one-to-one compare it to Java, it's not that much different, right? You can just declare an integer x and print it in a pretty similar way. So I guess here we switch screens.
Yeah, so I'll share my screen.
Okay. Let me alt tab to the right thing. Did it do it?
So here, if you're able to follow the QR code, you should be seeing something a little bit like this. If not, you can go to godbolt.org up here to see pretty much the same thing. So first of all, a couple of things we won't be getting into. What Godbolt's usually used for is typing in a short script like this or a short program and seeing the assembly it compiles to. And these colors here are for seeing what corresponds to what. So here, this is our return 0. We won't need that. I'm going to turn that off. So I can go to the settings and disable the colorization. And also switch to the tab where we can see the output of the program. So here, instead of seeing the assembly, we see that this program just prints out x equals 42.
Need to. I will keep it open, right?
Yeah.
Okay.
Okay, now some basic syntax for more than just printing a variable. A lot of things are practically identical to Java. So you have your if, else, statements. You have your while statement, your for statement. Inside of these loops, you can do continue, break. There is also exception handling in C++. You can do try catch. We just strongly discourage it because it's much more efficient in Java than in C++, or rather in C++, it's just expensive while everything else is fast. There's also label and goto in C++, just like Java, but you should not be using this in either language if you ever see that you're doing something wrong. Then you have your standard operations. So you can just do logic with assignments, inverting, taking an and or an or of two Boolean things. You have your mathematics, you have your comparisons. It's all very similar to Java so far. There's one small exception that you will probably run into immediately when you try to do string handling in C++. So if you try to concatenate strings like you would in Java, so let's take the example on the left, right? You have hello, you have a space, you have world, and you concatenate these with a plus, you're going to get a compilation error. Now, why is that? Strings in C++ are not like strings in Java. They are instead more like a character array. So you're trying to add arrays, which doesn't make much sense. The way to easily fix this is create a string object from all of these character arrays, and then you can do all of your usual string operations. It looks a bit ugly. And if you ever try to do something like this, it's probably better to just change your print line to do everything inside of the print line with arguments, instead of concatenating it like this.
Actually, really quickly, or should I show my code?
Yes.
Some of you might be wondering about that SD print. Since a lot of you already know C++, you've probably learned with SDCL. Does that ring a bell for anyone? Yeah. And you know how much SDCL sucks? Yeah. In C++ 23, they introduced SD print, which is just a much nicer way of printing things. Makes it a lot more like other languages you'll be familiar with. It's also potentially more performant and just more ergonomic in general, in my opinion. So throughout this presentation, we'll be using SD print.
All right. This is the wrong.
All right, there.
This, it's a bit janky with switching windows. Oh, well.
Okay, so we have a slightly more advanced demo again. If you want, you can scan this QR code or type the link.
I think this was the Fibonacci example, right?
Mm-hmm.
So we give you like 20 seconds to enter this and open it on your laptop.
Sorry for all the QR codes.
I think there will be only one more, so.
All right, good moment. I'll share my screen now.
Let me first show what's on there.
Okay, so on this link, you should find a Fibonacci example, which shows a few things. One is that functions are also very similar to Java functions. You can just define this fib function and call it recursively, no problem. You also have a ternary operator, just like Java, with the question mark colon syntax, works exactly the same. And well, like I said before, recursion also completely fine, no problem there. Of course, you've all seen from algorithm classes that recursion is bad if not done correctly. So let's do a live demo of removing the recursion in a C++ function.
It's still very janky.
So here, briefly thinking about why we might not want to use recursion. Can anyone tell me why this is an inefficient way of calculating the Fibonacci sequence? Yeah? Yeah, it's exponential because, of course, each of these is being recomputed even if we've already done it before. So this is really a pretty bad algorithm. So I'm going to show you a slightly better algorithm, which you would probably already know. Should I just go right ahead?
Yes.
Yeah. So first, I think we can keep this special case for the first two steps. So if n is less than 1, we'll just return n. And I'll put that on one line. So that handles cases 0 and cases 1. But for the future, for everything past 1, we'll need to add the two previous numbers, right? So starting with, say, the value at n minus 1 is going to be starting at 1. And n minus 2, so 0, is going to start at 0. And now we can implement this with a for loop, so it'll be linear time. So for starting from 2, because we've already handled the first two cases. And here, can anyone tell me what our new value is going to be at each step? Yeah? Exactly. So we'll have a value current. Actually, we need to declare this outside the loop. So current. And then, of course, we need to update our values at -1 and -2. So and then at the very end, we need to return our current value at n. And here we get our value. And I haven't benchmarked this, but this should be a much faster function than the previous one. Does that make sense to everyone? Yeah? All right, thanks.
All right, so that was a very elaborate way of saying, well, that looks mostly like Java, not that many differences. These two examples, you could just copy paste Java code and change some print lines and stuff. Right? Okay, so I saw a lot of hands for people that have already used C++ before, so I think someone can answer this question. From anyone that has used C++ before, what is the part that you notice differs the most? Okay, he said pointers. Structures and classes. Manual memory management. Okay, one more. Operator overloading. Okay, it is somewhere on the examples. It's not the one I was going to talk about. The other three are the one I'm going to talk about. So thanks for your interesting answer. It will come back once. But yes, I agree with all the other three examples. It's definitely, at least for me, memory and data management. And we'll get into why. So this is an entire section dedicated to this because it's also the point where you're probably going to make the most mistakes when you're switching from any other language like Java, C#, Python to C++. So time to take off the training wheels of these examples and go into something slightly more difficult. And I'd like to start with pointing to the way Java works as a baseline. In Java, you have a rough distinction of variables into two classes. So you have your primitive types on the left, like if you have, let's say, an integer. The way that an integer works is if you copy the integer. So let's say we have A is 0 and we copy it to B, B is A. Then anything you would do to B has zero influence on A. These two are independent. So you're just copying a value and now the content is completely independent. Then you have reference types, such as an object or an array. in Java, which is basically everything else, right? If you copy a reference, the content that's inside of this object or array is completely synchronized, no matter how many copies you make. So if we make a list and we copy it from A to B, we change it in B by adding an element. It's now also an A. There was no memory copy being made. It's just copying the reference to this object in memory. Let's compare that with C++. So here's quick notes. You can just read this vector of string as being the same thing as the string array list in Java. So what I want to claim is in C++, everything is like a Java primitive. If we copy a list of strings in C++, like here, you just do B is A. Now we add something to list B. It's not in list A. That means that you are constantly making memory copies of the content. So you will be duplicating a lot of data if you do it the Java way. This becomes very important when you start calling functions or return data from functions, because there it also applies. If you are passing a vector of strings, so a list of strings, to a function somewhere, then the entire list is copied into this function. And of course, this is not good. If your list is a gigabyte, this is not what we want. So let's see how people would fix this. This is where pointers come in, one of the examples from before. There's a lot of red on this slide because I'm already going to spoil you by saying that you should not be using these. A pointer is basically a number that references a part of your memory. So this was a pretty old way to handle passing data around. Let's say we have value x is 42, an integer. Then we can say, okay, I want the memory address where this integer is stored. Give me the memory address, and we will put an ampersand. You store it in an integer pointer, which is what that little asterisk at the end means. And then we can print this to see what its value is. So if you see here, it's some random hexadecimal address somewhere in my memory. And if you want to access the value again at that location in memory, you use the asterisk at the start of a pointer, and then you can get the variable back. So as you can see here, we take x2 is asterisk of x pointer, and then we get 42 again. However, you can forget about this. This is not what you should be doing in C++. If you're using these, you're using very old ways of handling data. Instead, what you should be using to pass data around is references. So references are a lot nicer and cleaner. They refer not to a memory address, but they refer to a variable somewhere. And this is the correct way to pass data around. The only thing you have to do to make a reference of something is when you're creating a variable and setting it equal to another variable, is add an ampersand to the end of the type. And yes, this is a little bit confusing because pointers also use an ampersand in front of a variable. But if you just remember ampersand at the end of the type means reference, it will be okay. It's much safer because of the abstraction that this adds, because you have no operation to ask what is a reference to a variable x or the value at a reference of x. No, everything is handled for you and abstracted away. So now I have a quick question for you guys. What do you think that the second and the fourth print line here in this example will print to the console? Does anyone know the answer? Before in the pointer example, you would actually get the memory address right on the second print, but now we're just printing a reference. And on the bottom, we have two modifications. First, we have the reference being changed to something, and then a copy of the reference being changed to something. So question, oh, I see a finger there. Sorry? Yes? Yes, correct. So the answer is the first one will just print the value, so it's 42. Even though it's a reference, you're not printing any memory address, you're actually just printing the value, so it's 42. And then the second print that is highlighted, you will get 43, not 44, because we're changing the reference to be 43 and then the value copy to be 44. That is correct.
I think we have another question. Yeah, I can answer.
You can answer if you want.
This is actually a little bit more advanced than syntactic sugar and pointers because first of all, it guarantees that your pointer is never null, which is a nice thing to have. But it also allows the compiler to do a lot of optimizations under the assumption that it's never going to be null. Generally, I think of it as a way to avoid copies that doesn't require getting a pointer to something.
So the answer is it depends. Like a lot of things, it depends on what your compiler decides to do with it, because you're declaring intent. You want to refer to it. If the compiler wants to handle it with a pointer, in theory, I think it would be legal for the compiler to do it, but most compilers will try to do smarter optimization.
I don't know C restrict, to be honest.
It's the only one to point to that memory address, so it doesn't have to continuously reread that thing that you get. It knows that it hasn't changed.
So as I understand, you're talking about preventing aliasing. References do not prevent aliasing, but they do give the compiler a lot more visibility into what your code is doing because you're kind of representing it symbolically. And so often, but not always, the compiler can identify when you don't have two references to the same thing, and it can make those optimizations automatically. And so you can write C++ code that is as fast or faster than an XC code.
Okay, let's continue. So you've seen references are pretty great. You just add an ampersand to your types and you're done. It will behave identical to underlying values, right? You never get a memory address somewhere. And you don't need any copies anymore. You're just referring to a variable. If you do this on an object or an array, and it's a pretty big size, then this copy prevention mechanism is very helpful. It will make your code more efficient. However, there is one problem with just using references everywhere. And that is that because you're now referring to an existing variable somewhere, you can change the original variable if you use them incorrectly. So here's an example with an add1 function. We are passing a reference to an existing variable. We are incrementing it by 1 and then returning that variable. So now when you print the original variable and print the add1 result, both of them will be 4 because the original variable will have changed. We will show you in a little bit how to prevent this, but this is a danger that you need to watch out for. So if you learn anything today, please let it be this. Don't use pointers, use references when you can. Okay, there's a question? Yes, arrays are implicitly pointers, but we're going to show you a safer way of handling arrays in a bit as well with syntactic sugar from C++.
Don't use arrays either, basically.
But SD array is fine, right?
Don't use arrays directly.
Don't use C-style arrays, so not the old ones. But we will show you in a little bit which arrays are safe to use. Okay, so question 4. I see another hand. Yes, it doesn't matter what object it is. If you're passing it without a reference or a pointer, please don't use pointers. But if you are passing the pointer, you're not making copy. If you are just passing the value, it's copying the entirety of the object. Okay, now, question for the audience. What would this do? In Java, you get a compilation error, right? You're not allowed to do this, but what does it do in C++? Does anyone know? Okay, the answer is it will print a seemingly random value from what is already on your memory. Anyone else has a different answer? It depends on where X is. So let's say for now it is in main, but yes, if you declare it somewhere else, it might behave differently. Okay, so the correct answer is we don't know. You will not have a clue. Most of the time, the first answer is correct, that you're going to get random memory values, but your compiler is allowed to do with it whatever it wants. So sometimes if you're compiling it on Microsoft Visual Studio, it's going to give, like Visual C++, it's going to give you the results you expect. And then when you do it in GCC on Linux, it doesn't. So this is very dangerous. You don't know what it will be until you actually try. So variables don't have default values unless you specifically request it. If you don't request it, you're going to get compiler-dependent noise, is what I call it. As you see here on the example, you can initialize it. And also a small side note, here's the array that you should be using if you want a fixed size array. It's called std array. But okay, if you create an array, but you don't initialize it, there will be indeed seemingly random noise if you print the second variable value inside of the array. But if you initialize it with curly braces, then you will get something sensible. So in this case, if it's an integer array, everything will be set to 0. Same thing with objects. You have not seen class syntax yet, but if you have an object and you don't initialize it, there will also be compiler-dependent noise in there. If you initialize it with curly braces, then everything will be as expected. That brings me to the final point of allocation. Since you've now seen if you create a variable on the stack and you don't initialize it, you get random noise. But if you do initialize it, you get a default value. How would you represent null in this language? Which is very common in Java, right? You have nulls everywhere to initially create fields. Well, in C++, there is no default null in most objects, which is, in our opinion, pretty good. It prevents you from bad programming practices where you get random null pointer exceptions everywhere in Java. If you want to have nullability in your program, there is a way to specify this, and it's called std optional. So this is a construct that you can use to say, I want, in this case, a character or no. Then in Java, you would do this is not equal to null check. In C++, you would do has value. And if you ever try to access the value without doing a check, you're going to get an interpretable trash, which is very nice for C++ standards compared to what you would otherwise get. So you get bad optional access. So if you ever feel the need to use nulls, then this exists, but most of the time you don't really need it, especially for CG assignments. Okay, so now we're going to get into, I think, the final topic of the memory aspect. And this is, as a side note, pretty dependent on what platform you're on and what device you're on. So as a general question for all programming language, it's very important to know where are my variables actually stored. If I create a list, if I create any block of memory, where is it being held? Well, many languages and many platforms try to separate these data structures depending on their size. Then you have some very small microcontrollers that maybe do not. So again, it's dependent on what you're compiling for, what you're developing for. But in most platforms, in most devices, you have a very small stack, which you're using for your local state. So what functions are being called, what are your small integers inside your function? And then you have a massive heap for large data chunks. So for example, arrays with a gigabyte of data in it. Now let's try to look at Java and C++ side by side. Okay, so I assume most of you have already seen this before, but where are primitives stored in Java? Let's see if people know. I see a hand there again. Yes. So primitives are on the stack. Where are objects in Java? Yes, so it's a reference on the stack, but the data is on the heap. I just put on the heap, but you're totally correct. And then arrays. Yes. Arrays in Java are basically the same as objects, like the answer said. So for Java, you get your big data chunk on stack, sorry, on the heap. And then you get a pointer on the stack that lets you work with this data. Now let's take a look at C++. Where would an integer in C++ be stored? Okay, and I think there's two people answering most of the questions now, but I don't mind. Yes, so the answer is it depends on where you create it, but by default, if you just do x is 5, it will be on the stack, which is correct. What about objects in C++? Let's see, can we get someone else? In the back? Sorry, I couldn't catch the last part.
Okay, good.
I think it's by default, no matter which compiler you use on the stack, right?
So
Sure.
this is sort of an implementation detail. But generally, when we're talking about stack and heap, in C++, the key thing is that you get to choose. So if you want something to be on the heap, you have to put it on the heap. And if you want something to be on the stack, use the normal constructor, and it'll be on the stack by default.
Yeah, so the answer, the start was, it's also going to be on stack if a primitive is on the stack. And the point that I was trying to make with this slide is that there is no distinction between a primitive and an object in C++. You have to choose where you want to store something. By default, in most implementations, you are going to put a primitive, an object, or even an array on the stack, unless you choose to put it on the heap. But yes, it's an implementation detail, and there will be exotic devices where maybe it will be put on the heap by default, and it's a compiler choice as well. For your knowledge or your implementation of CG stuff, the important thing to know is that you are putting a lot of data in this 1 megabyte. So yes, like you said, you are allowed to put a single integer, or I think someone else had it as well, on the heap if you choose to do so. Yes? Yes. So pointers are needed to handle heap data most of the time, but you can use pointers just fine for stack data too. So yes. So the example I showed before with the pointer, everything was on the stack. There was no heap stuff going. Everything was inside of that 1 megabyte. So pointers, you can use them just as well for stack data as for heap data. It's just that it's very hard to handle heap data without pointers. But we will see how to do it in, I think, the second part. Okay, well, let's continue. So the problem here is that you're now putting everything on a 1 megabyte stack. And if you want to make a 1 gigabyte array, that becomes a slight problem. So here's an example. If I'm defining an array here, in Java, of course, this will be put on the heap. Here it's put on the 1 megabyte stack. So you got to be very careful with this. Then the question is, how would you now access this massive heap? The way you do it is you can request, showing a little bit how a big block on the heap of, for example, a class or an array. Then you get this massive chunk of memory allocated to you. And once you have it, you need to know slightly different syntax to access data inside of it. So usually when you have an object or anything, you would use a dot to access fields and methods. In this case, you have to use this weird hyphen greater than, or you can call it a pointer, but it's not actually a pointer, it's like an arrow. The important thing is, please don't try to implement this yourself. So don't write new and delete, even though people let you do it. That would be the old way of allocating your own memory. There are a lot of nice standard library features that let you get access to this heap. So the one I use here is a shared pointer with the main shared function. And this one is super nice because it works basically like a Java or C# or Python object where you can just copy it around. And when all of the references to the object are gone, the object is deleted from memory and you get memory back. So that's basically how you can recreate Java if you want, just make shared pointers everywhere. You also have unique pointer, which is a special case. I don't think you really need it, but it exists. And interestingly, the vector that I showed before as an example of the Java array list is also on the heap by default. That's why you can just also add a gigabyte of data inside of it if you want. Nice thing for you guys is with the CG framework, you are probably not going to have to touch any of this because the CG framework already does some heap allocation for you.
Think we're running behind on time?
Speaking about the standard library, we are quickly going to go over the standard library. And I'm going to give the word to Jackson for that.
I'll be a little bit quick because you're probably already familiar with the concept of standard library. But I think it's worth going over for C++, first of all, because if your curriculum was anything like mine, you haven't been able to use very much of a standard library before, right? You've been implementing things like merge sort yourself. And so maybe show of hands, have any of you really gotten to thoroughly use a standard library in a language before? Yeah, that's not what I thought. You're both implementing like extendable arrays, right? So this is a nice opportunity. The right direction. To learn about what's available in C++, and actually quite a bit is available. The first thing to know about the standard library is that it's massive. You can fill several data structures and algorithms courses, and then some. The other thing to know is that it's very flexible. So first of all, before you're committed to implementing some algorithm that you need, I would browse the catalog and make sure it doesn't already exist. So now, first of all, the standard library provides a lot of algorithms. So these range in complexity. Everything from STD swaps, which uses references to switch the values of a pair of variables. And that's really useful if you've ever implemented something like a sort where you're constantly declaring a TMP variable that's able to swap two values. But you probably won't actually need to use that because you'll be using STD sort for sorting. And the cool thing about STD sort is that it'll work on any item type. So you can sort integers, or in this case, we actually sort the characters in a string, which turns Jackson into actions. And the neat thing is, even if you have a type that wouldn't normally be sortable, you can define a way of sorting it and use SG sort. So it's very generic, very flexible, and that's true for most standard library algorithms. The other cool thing about the standard library is that it's extremely well optimized. Companies like Intel actually spend a lot of time, or a lot of developer time, improving the standard library with compilers. And in fact, Intel does the reverse, and they'll design their CPUs so that they run the standard library very well. So it's difficult to outperform SG sort. It's possible, but you're probably not going to be the one to do it. People pay a lot to make that. The other thing the standard library provides is a lot of containers. You've already seen std array for fixed size arrays, std vector, but there's also anything else you can think of, right? Heaps, stacks, queues, maps, an alphabet of different types. And what's really nice is these containers are designed to work well with the algorithms that are provided. You can sort a vector, sort an array, and so on, but you can't sort an empty list, a linked list. Can anyone tell me why you might not be able to use the standard libraries for the linked list? Yeah? Yeah, that's a good answer from someone who's familiar with C++. Does anyone have another example that's more general? Why you might not want to sort a linked list? Yeah? It actually chooses the algorithm dynamically depending on the nature of the data.
Okay, or table algorithm has random access and STD list, linked list is overbound where access in the middle.
Exactly,
And you're
yeah.
accessing every element that's and but reports.
Yeah, accessing elements in linked lists is super slow, and that makes them really a terrible data structure for sorting. Okay, you didn't hear this from me, but linked lists are terrible for everything. Never use linked lists. You probably implemented a few, but you'll never use them. And in fact, sorry to disappoint you, but as great as this whole selection of data structures is, you're pretty much always going to be using SC vector. Probably 19 times out of 20, it's going to be the right data structure for the job. It's just nice and fast data, has all the features we need, and most algorithms will be faster than SC vector. The others have been niche, right? You can't replace a match, but they are niche. Okay, now you probably noticed a lot of SV : in this section. And well, technically, it is possible to from Java import SV and bring that into the namespace, so you never have to type SV. I am going to say that you do not want to do that, because no matter how large you think the standard library is, it's larger. So you can always see, like, if you import that, then you can't name a variable swap. The swap is already a function. But there's hundreds and hundreds of names, and you just end up with a minefield of words you can't type. So please don't do that. I wanted to not show that at all, but don't use all of this. Okay, now this section is sort of where we transition from things you'll definitely need for the project to a more opinionated section about things I think you might want for the project. And I was kind of designing this presentation originally for people coming from Java. And part of this was getting them to write C++ that it wouldn't be upset to read. But since all of you are already familiar with C++, a lot of you probably have your own strong opinions about what good C++ looks like. So this is the short section. This is going to be a few tools I think are useful, and we'll go through it quickly. But if you see anything that you have a different opinion on, and you think I should be doing differently, I want to hear from you. So first, a useful feature with the SD : in mind is auto. So this lets you declare a variable without having to repeat the type name. And so if you have an SC string or an SC vector full of SC strings, it makes it much longer than that actually. Then you might want to use auto. If you want, you can use auto absolutely everywhere. I don't know if I would suggest that. There's a trade-off. I think there's a balance to reach. Are there any of these up here that you think would be a bad idea and could cause problems? For someone who hasn't said anything yet? Yeah, I kind of gave that one away as a hint, right? What type is B going to be? We don't know. And so that could be a problem. Yes?
Defining any variable which we can't visibly see the type.
Yeah, so that could mean that you always want to be able to see the type somewhere. Like, this is good, but this is bad. Right? But there could just easily be the opposite opinion that sometimes you want to not write the type. And anyone think of a reason you might not want to write the type? Ignoring length? Yeah? Yeah, so for each is a great example. And I usually use auto when I'm doing a for each. Any other examples where you might not want to know the type? Yeah.
getting an iterator, write out the 100 character, whatever it is.
Yeah, not to get into iterators in this presentation, but yes, always use auto with iterators, otherwise you get a page of type. The example that I like is here, we have a person with an age. And right now, say that age is defined as an integer. If you have a link, you'll see that it is. But down the line, I think, oh, you know what? That's dumb. I'm not going to have a negative age. Why would I use a signed integer for the age? I'll switch that to an unsigned integer. And if I use int there, then everywhere I had a person and I got the age, I would need to change my code. But if I always use auto, and I trust that that's going to be some kind of reasonable number type, float, int, whatever, then it's easy to do refactoring like that. And so auto can be a useful tool for keeping your code easy to refactor. Any questions? All right. Another thing which I'm going to spend a few slides on because I think it's very important is const. Are most people here already familiar with const? Show of hands. Okay, that's good. Most people. So for those who haven't seen before, const lets you mark a variable as unchangeable, so immutable. So here, in that earlier example, you remember we had our function that added 1 to x, but it also added 1 that we passed to it, and that's really confusing. Usually, my opinion, all functions should be like this. Usually, you don't want a function to change its input. That's just confusing. If you write C, you might have different opinions. And so this lets you prevent a lot of mistakes. So here, the compiler would catch this. It would tell you, hey, you can't change x because it was passed in as const. And usually your IDE will also put a yellow speaking line warning you that there's a problem there. The other thing you might use this for, why you want to construct, is if you're passing an especially safe type, you don't want to modify this input, but you don't want to make a copy. And so when I'm writing code, I use const references very frequently. Another place to put const is on an entire method. So here, this just says that this method foo isn't allowed to modify my first class. So that can also prevent mistakes. If you think back to Java, lots of getters and setters. Getters will usually be const because you don't want getting value to change the value. Setters will usually not be const because when you want to change the value, you got to change the value. Where this gets really useful is when you combine it with, say, here we have a const variable that can't be changed at all. If you imagine you were passed like a reference to a database into your function and it's marked with const, it's almost like you have a read-only access to it, right? And so this read-only, you can't call any of the setters for Java. Word of warning, use const liberally and early. When I'm writing code, I usually start by writing all the signatures of the functions, and I put const everywhere I possibly can. And only if I don't, or only if I find out I need to change something, then I remove the const. This sort of overstates it. It's not so hard to add const to old code, but it's not as easy as you might like it to be. Okay, one more thing. For each loops, you're probably all already familiar with them from Java, from other languages. Hopefully you already love for each loops. They're pretty great. But in C++, they're even more important because unlike with some other languages, you have less protections to prevent you from accessing a, I don't know, fifth element of a 4-element array. That'll compile or run. It could cause unexpected behavior. And I'll get into why that can be really bad in the future. But for now, suffice to say, you don't want to do outbound access, unlike with Java. And so you use a for each loop, and that guarantees that you're never going to access past the end of your array.
Could we skip span maybe?
Okay, maybe we can breathe through span. Span's pretty neat. It lets you take a vector or an array and treat them as the same thing. You might see this as an alternative using a template function. I won't get into templates in the presentation as much as I'm strongly tempted to, because I really like templates. But I'll save you that.
There was a live demo supposed to be here, but we are running behind on time. So I think if someone wants the link, you can copy it from here or scan the code, but we're not going to do the live demo. We're going to very quickly do a quiz and then have a break. Does anyone still want to scan the link? Give you like 5 seconds. Okay. Let's do a very quick quiz before we have a break. So I've shown you some things about how C++ references work. I've shown you a little bit about Java's memory model. Now a question for you guys. Who here thinks C++ references are equal to Java references? Please raise your hand. Okay, that seems like 0 hands. Oh, wait. No, okay, still 0 hands. Who here thinks they are not equal? Okay, that's good intuition. I have an example here on the slide showing exactly why they're different. In Java, when you pass, for example, an argument here, but also when you're making a copy. Oh yeah, that works, thanks. Also, when you're making a copy, you are sort of copying a pointer to the data. So if you were to now override it with, for example, a new list, like you can see on line 2 of the Java version, that doesn't influence anything outside of this method because you're just overriding the pointer to point to some other memory location inside of the function. In C++, when you override a reference, it overrides the entire content of the memory in the original location as well. So if you just quickly take a look here, the left one will crash because you are adding an element to a new array list, but it's not updated outside of the method modify. So this .get0 will crash. In the C++ version, you're allowed to just override a vector if it's a reference. Use const if you don't want this behavior, right? And that means that if you then print it, even after overriding it, it will just print 42 just fine. Okay, last quiz question. This one is more interesting. So who here thinks the references are exit safe? So you can always read a reference and there will never be any noise there. No hands? Oh, I see one hand. Who here thinks they are not safe? Okay, that's a strong majority. You guys would be fast at making a coalition. Unfortunately, references are not safe because they have scoping issues. It is legal to return a reference to a variable inside of your current scope and then pass it to a location outside of that scope where now the reference points to something that doesn't exist anymore. So very quick example here. I pass a value 42 inside of a function as its argument. Then I make a reference to that argument. And then I return a reference to that reference. This is legal. You can do this in any compiler I've tested. The problem is that after you return it, the original value b, the argument, doesn't exist anymore. So now you are going to get compiler-dependent noise again. On Visual C++, you're going to get minus whatever this is. In GCC and Godbolt, you're going to get 0. Okay, so we are running a little bit behind, but let's give you a 10 minutes. Let's do 10-minute break.
10 minutes.
Let's do a 10-minute break. Then we'll see you after.
Yes. How far behind are we?
We basically can complete in 45 minutes, I think.
Hey, question. You said there's no knowledge because I remember using when I was traversing character arrays, traversing them until the null.
Yes, that is a different null. That is a byte with 0 as its value. So In Java, null basically means it's a pointer to nothing. You have null pointers in C++, which we tell people not to use it. With strings, they are null terminated, which means that they're just a byte with the value 0 at the end. Every byte is one character, or you can have 2 bytes as well. Hi, hope that's not confusing.
I don't know if I can run like visual code often into expert because they say I can either download this, but I don't know. Like this probably make your Mac pretty slow.
Oh, yeah.
And the second option is to just download Visual Code Studio with the Xcode command line tools.
We'll go into this, but you don't have to use Visual Studio. You can choose whatever IDE you like. If you have one you already prefer.
The important keyword is CMake. Anything that supports CMake will be okay. I will show it immediately after the break.
It's like the equivalent of IntelliJ if you learn Java.
CMake is not an IDE. It is a standard that a lot of IDEs will read as its format. So basically everything supports CMake. Oh, C-Line is an IDE.
Yeah,
Have you heard of C-Line? For me?
we have a list, but yeah, C-Line's pretty good on the list.
Okay.
Yeah, I think it's
If I use C9, I will also be able to use a lot of extended.
yeah.
Okay, great.
Yeah, the assignment shouldn't require a specific ID. I don't think so.
We're not in charge
C-Line
of the setup guide, so I hope
the
it's going to be as simple as possible.
There's them, right? No, we're trying to go there. Next time.
I'm going to quickly go to the toilet. I think.
Yeah, go ahead.
Hi.
You have a question?
No. You do Unity in C?
Oh,
Yeah. So I do that too. Yeah, that's my function.
Yeah, he'll be back from back. It's really funny because the other guy, like, I'm in my project, and he worked next to the same project. Yeah. Yeah, I don't remember what part you did. There are some good trends I tried to say. It's but it's like you're getting more ingredient space. It's not like yeah. Yeah, but you know, I think participating on the oh, I might have read years of study you. Yeah, yeah, it was like a study where
Safe.
you
Hey man. How did you schedule it? Your friend is Omar. That's crazy. You know Omar. Oh, yes. Wait, no.
The study, gotta be honest, the paper has some mistakes. I mean, it's a thesis project, so it's like not academic.
I'm doing a presentation.
It's a good paper for like
I know you.
like I did few mistakes in like formulas. It's like because I teach in San Francisco, like there is like a formula.
Yeah,
Like one place where I keep had
Wow.
like if you calculated right, if
How are
you
you? Good? Fancy BSA?
if you gave like some extra context, like another context you gave, it was wrong.
Yeah.
Like the result.
What's your name? And to
Yeah, it's
making so there's
making I still like to develop my laptop like
You go to
but I still have to like
oh, yeah, dude, this is like 3 fucking years.
if they get very sound
Okay, let me send it to you.
but that one
Homework so like
That's okay.
You have a question?
Yeah, sorry. Part of the student presentation, maybe that's not. And I wonder if I could do that.
Maybe at the end of the course.
Okay.
What are you presenting?
Basically, just who we are. We do competition and company events. It's only like 1 or 2 months.
Yeah, of course.
Yeah. So at the end of the course, the painter right after the break.
I think I'm gonna do it. We're running short on time, I think.
Thanks.
I didn't really do any program. I was just there to help organize one showing. And I know the students quite well, but
Because I'm one of the students then.
you're also working on it.
Yep, I am doing it my own.
That's really nice.
I'm doing the.
Okay.
You'll have it at the end.
All right.
I'm gonna interview like the last few slides.
Jump scares with
Really nice. Trying to get that to work with all of the like portals to
Well, I mean, we use
What
them.
are you going to talk about in the second session?
Next, Amir's gonna go into some of the practical stuff, and then I'll talk about undefined behavior and some pitfalls in C++.
the flies.
Yeah,
And
like,
you don't have to stay for the whole thing if you don't want to, though.
yeah, and like also,
Yeah, now that he told.
the like
I know it's going to be,
All right.
I thought about the project.
Yeah.
like
that
with
they're going to work on.
Yeah.
which
Mhm.
means you cannot pre-bake.
Yeah, I think that'll mostly be the TAs helping.
How would you pre-bake lighting in hyperbolic space though?
Much time do we
Because there's
have?
no way Unity to
We have 30 minutes.
pre-bake in such course.
But I was thinking one thing,
That's not
when
problem,
somebody
it's like trigger him with
there's a question or an answer,
Uh-huh.
if you can repeat it, it would be like,
Yeah, I realized I wasn't doing that.
Custom shader. I like a light map. Like,
Okay, sure. If that works, that would be.
I assume that.
They're gonna present something at the end.
pre-baking them like beforehand on release it, right? And I'm not going to make like the most like advanced like lighting. It's just simple lighting from shadows and like.
Okay.
You know, if I get fancy, I can maybe do some like reflections. I don't know, reflections.
Is the real-time lighting system not good enough for Quest 2? I think it would be easier than trying to.
Real-time lighting is very, like most Western
Yeah.
games don't use it.
Yeah, that's the like the problem with real-time lighting is shadows.
Kijk, hij heeft gedaan.
I've never tried it on Quest 2. My slowest
Ik heb
light is Quest 2.
slides on site.
Ah,
We will.
I did run into all
First.
I see now.
Yeah, right at the end.
I do, I do.
I think right at the end.
Like VR stuff.
Sorry for the QR code.
You can check that.
What?
You can
Made,
check it. They should,
uh,
if it's gonna open after
I
the
made,
somebody planted on
You know, Just Dance.
But we haven't uploaded the slide.
Yeah, I assume you didn't make
It's
it.
not gonna be
No,
after
well,
the lecture,
I recreated it in VR chat.
later today.
Oh,
You know,
Uh-huh.
you know VR chat?
Yeah.
Yeah.
If you can upload slides and basically say that they.
Yeah, so I made like a long vision for this.
That's neat. I think we were worried about last minute changes.
Yeah.
I don't think. Oh, I'm sorry. Yeah. I'm looking now at trying to define all the stuff on the screen. It's like. They can always find. The only 28. There's always stuff going on. I need to very quickly stop something for 45 minutes because we are kind of behind on schedule. Can we skip anything from the coming slides? Is there anything that's, so I have the headers, then I have a little bit on OOP, which is shortened.
Mhm.
The CMake thing, I can't skip these things, right? Can it? I don't think skipping objects is a good idea. CMake, headers. Headers is quite long. That's the thing I'm afraid of.
I think you can speed through headers, but
Yeah.
maybe the
I will try to speed through this. Then there's
ties present objects, because I think we were discussing whether you could have
yeah, but I mean,
pitfalls I can also speed through.
so this is just visibility keywords, how to split it, object creation, and the response references. That's all I have. And then we have the pitfalls. I think it will take quite long to go through headers, though, to have a good explanation.
Yeah, maybe we can skim headers. I don't know how those work.
But it's the most confusing part of projects in C++.
But we provide them that, and the Matthias didn't go over it, right?
No, he did. Like, that's the part I copied from the text,
So
basically.
then, yeah, maybe keep it.
So
I guess just no questions and as fast as you can, and I'll do this.
there are no questions there, I think. There's no live demos anymore.
Uh-huh.
So that should be okay. But yeah, it's unfortunate. I'm just warning you now that I have to skip through a little bit.
No worries.
That's
Yeah, I
that's
didn't
start-
find myself in the practice. I should have.
I also didn't. It's my fault, bro. Like I took like 35 minutes or something when I said 20 minutes.
I think I also went over them.
But it's 3-1. Let's start 3-5 straight. I will make a announcement again. Then we have 40 minutes. I think we have less quiz and will be a good crowd.
Who's on the right? You have Lucas and yours?
Lucas and yours.
Very quickly.
The question.
Yes.
Yeah.
I like C, and I like doing pointers, I like playing with them and touching them inappropriately. And I feel like this is forcing me to do Java in my C.
This was a conscious decision because we're expecting your students from both names to Java. You can write C in your C++ if you want. And you are exposing yourself to danger. It is a personal preference. I have a strong preference. I'll kind of go into why I have it later on. But there's nothing I can do to stop you. And nowadays, luckily, the code isn't graded anymore. So I don't have to read your code. I do whatever you want. And if you already have a preference to write C style C++, then there's nothing I can do to help you.
I like what? Like sometimes I like living a bit more dangerous, but not. I've never used standard array. I didn't know println was a thing. I just used printf or cout.
Yeah, it's new. Printline is pretty new.
Isn't it just equivalent to printf?
No, printf needs you to specify a format and takes unchecked types. I had an example of it before, but I cut it because it was already too long. It's somewhere in the extras at the end.
You do Python style, bracketed format strings.
But it also checks types beforehand
Yeah, and it checks types.
during compilation, which is really nice.
I don't think you'll run into any problems.
Fine, this one.
Thinking about the references.
I got my telephone here for the board.
I'll figure that out. But I think.
So,
I kind of know about the first thing.
I hope so. So the thing is, we are basically giving a guest lecture here.
Yeah.
We're not in charge of the organization, not as professors. So we assume they will.
How much being yes, why it's like
Yes.
primitive C++, let's say.
Not at all.
Like
Honestly,
E and not quite.
I think you're mostly writing just inside functions, but it's not going to be.
So
I think we should really get started.
Oh yeah, sorry. Thanks for the question, though.
Hey, everyone. Can everyone take a seat again?
You also have all of it. So yeah, okay. Timer. Basically around 25, I hope to be done. And you have like 10-ish minutes for Bitcoin.
Sounds good. Yeah, I think you can start talking. You can start talking, I think, or if not all on the stage.
All right, I hope everyone had a nice break. Got a coffee, tea, cola, whatever you prefer. Water, sorry, I should be saying water. Um, Time to continue with the second part of our lecture. So the first part so far is really focused on single file development. That's why it's so easy to prototype in Godel, right? You just have a single file, throw everything in there. But a real project, fortunately or unfortunately, is not just a single file. Okay, if someone does do everything in a single file, I'm sorry. But usually you would have some kind of project with a lot of files in them. And if you're coming from Java, the structure of the project will be a little bit alien to you. So we're going to go over it, especially since you'll be working with the CG project in a little while. And that uses, unless they changed it, normal C++ project file structure. So let's get into that. Large projects, or otherwise known as CMake projects, most of the time. Yeah, sorry, we're using CMake. We're still using CMake, I'm sorry. Okay. There are a lot of C++ IDs to work in. So the most common one will probably be Visual Studio Community here. There is Visual Studio Code. There is Lions from JetBrains, which you might be familiar with because they also make IntelliJ. And there is Apple Xcode. And for the more daring Linux people here among us, you can also use Vim or Emacs. Perfectly fine to develop C++ there. How would you create a project in one of these items? Well, there are a bunch of different options. And the one we recommend for now, for most people, is this Visual Studio community example, CMake. So if you create a new project, you search for CMake. If it's not installed, install a template, and then you create it. The default project does something horrible. It's importing the standard library, so remove that part. But other than that, this should be what you need. For you guys, what's more interesting is probably opening an existing one. So if you open Visual Studio Community and you're greeted by the starting pop-up, it has open a local folder. If you then select a folder that's made with CMake, it will automatically set everything up. Or if you're inside a project and you cannot find this opening pop-up, then there's also open CMake and it will do the same thing. For computer graphics, starting, if my understanding is correct, tomorrow, there will be a CMake project available for you guys to do assignments in and to practice your programming skills. This one you can open with CMake just fine in any IDE you like. One small problem, or maybe big problem. By default, the project is still C++ 2020, not 2023. So there are a few things from our example that are missing. The most important one being that there is no std print, and you have to use very old ugly syntax with cout. However, I've asked, and it should be fine for you guys to just replace the 20 with 23 in the config file, and everything should work fine. Legal disclaimer that I was told I have to give is I don't know yet what's going to be on the exam at the end, your programming exam. So maybe it's not going to be possible to use the 23 features, and it will be 2020. If so, you also need to know the std cout syntax to print strings. I hope I can convince people that you're allowed to use 2023 on the exam, though. Okay, now let's get into this project. So let's say you've opened it in CMake and you want to figure out what's going on. And you're going to find a lot of .h files where you might not yet know what these are, why they are there. So we're going to start from the beginning again with a single source file. What you used to from Java is that you can just throw, let's say, 20 functions in a file or inside of a class. And all these functions can use each other however they see fit. So if you have 5 functions, they can all call each other in any order. You can have recursion in any other, no problem. C++ is slightly different. In C++, you have a compile order from top to bottom. So if you declare a function num on top, and in your main, you're using this function, that is perfectly fine, no problem, because it's already defined. But if you now move this function num to the bottom, suddenly you get a compile error without changing anything. And there's a way to then still use num from within the main function. It's called a forward declaration of a function. So at the top of the file, you just make a promise to the compiler that this function will exist somewhere. In this case, you just write int num and then semicolon, and then the compiler will know, okay, at some point this function exists, and this is what it looks like. No arguments, integer return type, perfectly fine. Now you can do the same thing. You can do Java, you can have your main function use num, you can use from within num the main function, so you probably don't want to. And it all works as expected. Next step, what you can also do is now you can start separating files. It's perfectly fine to then move the definition of num into a separate file. Because in the file with main, there is this promise to the compiler that the function num exists somewhere. Then you create the actual definition of the function num in a different file. And now the compiler can separately compile these 2 files and then merge them together into a final program. If you look at the contents of the intermediates, the left file will have an undefined num, which just means it exists somewhere, but it's not defined yet. And then the right file will only have a definition of num. And then when you link these together, you get a nice program. Let's say we now want to define another function called number squared, which just multiplies num by num. And we also create a new file for this, file C. You can see that there's already a bunch of clutter from all of these forward declarations popping up at the top of your file. But it works fine, right? You can compile this. Now you have both your file with the main and the file with the squared number, having a forward declaration for the original number function. But as your project grows and you have more and more functions that all of your other functions want to start using, you run into a problem. You're going to get hundreds of these forward declarations that are duplicated everywhere. Now imagine I have this num function, right? And I want to add an argument to it. And I have 500 other files using this num function. It's going to get ugly real quick. So we need a way to prevent all the duplication, just have it centralized in one place. And this is where header files come in. So the clean way of using header files is that they only show the forward declaration for the functions defined in the corresponding source file. So that's a .cpp file. Then in other files that want to use these functions, you can include the header file. And what this now does is the compiler will just copy paste what's in the header file into your source file that is using that header file and include. Quick note, there's a weird pragma once here. That is to prevent duplicating forward declarations when you're including the file multiple times. You might be wondering, why would you include it multiple times? Well, there's a reason you could accidentally do that when you have recursive dependencies, or more like linked dependencies within dependencies. But for now, just don't worry about it. Just put this hashtag pragma once on top of your files if you make anything, and it will be okay. Okay, now we know how to separate files a little bit when you have functions. What about objects? What about classes? We've not really discussed it yet, even though we had it on the slides a few times. Well, I just said, okay, you have your forward declarations in one file, in the header file, and your implementations of your functions in the source file, the other file. Going to be the same thing for classes. So you have your header on the left, which just declares what functions exist within a class. And then you have your source file, which has only the implementations for these functions. You don't have to do this, by the way. You're also, like, it's completely possible to just have the implementation inside of the class directly, but this is good practice. Then there's something weird you've not seen here yet. You have these weird public colon and private colon instead of in Java where every method and every field has a separate modifier. Here you can just have blocks. So it's a little bit cleaner in my opinion. Then the syntax for defining the implementation for a function in a source file uses the double colon syntax. So you have the class name, colon, colon, and then the method name when you're implementing it. Okay, I have my class definition. How do I now initialize one? An object from this class. This is where you get a lot of confusion from online documentation probably, because there's so many different ways of doing the C++. I am of the opinion, sorry if this offends anyone, that the correct way to do it is using curly braces. For reasons I don't want to get into much now. But basically, if you have, for example, a tuple from the standard library, and you want to construct it with 2 integer types, then you have the type, variable name, and then you initialize it by calling the constructor with these curly braces. So you have 1 as the first argument and 2 as the second argument. Then there are a bunch of variants that I have on top and on bottom. They do all sort of similar things, but most of the time you should be using the curly braces. Unless it doesn't work with curly braces, that's when you should switch to the normal braces. There is some difference in the order of your arguments and what actually happens under the hood, but most of the time you can skip the normal braces and use the curly braces. Okay, you created an object. How do you now use it? It's very similar to Java. You just have a dot to access its fields or its methods. I think this is actually identical syntax. But quick reminder, these objects are not on the heap like in Java. They are on the stack, and you are copying them every time you use them. So again, reminder, use const references when you actually want to pass them around. Like here, we have a integer point, and we have a length squared function. You want to have const point reference when you're passing it to not be making a copy of the entire object. And I think that's mostly it for objects. So other than that, it's just OOP like Java.
Yeah. Yes. So sorry to the sea lovers. I didn't realize there would be any in this room. Everyone else, this is the thing is, C++, I love it, but it's a language that's made of foot guns. There's so many different ways of shooting yourself in the foot. And yes, a lot of them involve C code. But first, I'll start with one of the common ways of hurting yourself in C++, which does not involve any C, and you can do it in modern C++. My favorite thing about C++ is that it's an extremely expressive language. It gives me, as a programmer, a lot of power to customize it and to do interesting things. Like here, if I have my nice number type that I want to use as a number, then I can implement operator plus, and that lets me add 2 of my numbers together. That's pretty great, right? That lets you write useful APIs for libraries. But one of the worst parts of C++ is that it's an incredibly expressive language, and it gives other programmers a lot of power, which they use to do the weirdest things, like implementing plus by multiplying. That's sort of a contrived example. You can imagine how that could be easily used. I would do questions, but we are running very tight on time, so it's a few in the end. But Another way you can hurt yourself is with templates. As I said, I really like templates. They let you do a lot. Think like Java generics on steroids on steroids. They're so powerful, they're Turing complete in the compiler. That's fun. And this is actually not an example of bad C++ code. This is a standard library. That's how SV sort can work on any type. I don't ask you to understand that. That's not even a function. That's a function signature. Okay, now the main part of this. A big challenge with C++ is that it's basically, technically not quite, a superset of C. So most C code will also run in C++. And I had an analogy here. If anyone who's played Portal 2, the game. Okay, that's a good number of you. So people get this joke? Yeah. C is like if you started out in this futuristic research facility and you can fall down this really deep pit into this old version from the 80s that's rusting away in toxic sludge, right? You can always have the option of venturing down into C land. You might get tetanus, and it'll be really hard to get back up to simple plus. This is the root cause for a lot of mistakes in simple plus. Now, you might think, now that I've warned you, you can avoid writing C. But that's not quite true, because as C++ has gotten a lot better, it's written a lot differently. But all of the old stuff that people have written about C++ and all the old C++ people have written is still floating around and trick you. So if you go to Stack Overflow, even I still see code like that every once in a while, and it'll be marked as the correct answer. It is not the correct answer. It means you harm. You should keep an eye on the date of Stack Overflow answers. If it's before like 2014, don't trust it. Sorry, remember your question. I will come back. Also be wary of chatbot code. ChatGPT can be useful, especially if you get like a 10-page error message trying to figure out what's going on. But if you have ChatGPT write your code, not only will it be trained on that old terrible C++ code, it doesn't have a date next to it. So you don't know if you're getting C code. So just be very careful. One way of spotting if you're dealing with C, again, C head will tell people notice this. If you see malloc, you're in the danger, you should run in the other direction. What's going on here is we ask for a bunch of bytes. We fill them up with data, print out some of the data, and at the end, we have to free them, give the data back to the OS. That way we don't have a memory leak. Now, when C++ was created, they thought, okay, this is terrible. Let's solve this. Let's create a new system. And it looks like this. So this might look familiar if you know Java. New gets your data, delete gets rid of data. But this is really just a C code again, right? The only thing that C is the 10 times size of the float, right? It doesn't solve anything. So I also suggest not using new and delete because there's a few types of mistakes we can make here. I guess first, here after we've created the data, you can't safely read it because it's uninitialized, right? You'll get junk data or compiler dependent noise, as Amir said. Once you've filled it up with data, it's safe. And then at the end, you have to remember to delete data. If you don't, you get a memory leak, which for small programs like you're doing in projects won't matter so much. But really hypothetical example, if something like a slide program had a memory leak, then I would need to refresh Microsoft PowerPoint every 45 minutes. Then it did bog down my computer. People do still write memory leaks, especially Microsoft. Microsoft's really good at that. Also, if you try and access B here, you'll get a site call for some other unexpected error. Because of course, you give it back that memory to the OS, you can't safely touch it. So, a lot of quick guns, right? A lot of different ways you can mess with yourself here. In modern C++, you never see new and delete. Instead, what you do is you create an SV vector, and then you use it. It's that simple. So there's a reason this is safe. The act of creating the data initializes it to reasonable values. And then at the end, can anyone tell me where we delete tags? Yeah? Exactly. So when A goes out of scope with this closed bracket, the destructor gets called, and that reads the data. And the great thing about doing it that way is, can you imagine what would happen if I moved this line up here to try and do use before initialization? And anyone tell me what would happen if I moved this line here? It's not a trick question, really, is that obvious? What is it? Yeah? Yeah, you won't be able to compile it because you can't activate it, right? It's just nonsense if I move that there, so it's obviously wrong. And same if I move this to after the close bracket, A doesn't even exist, right? How am I accessing it? So the error is really obvious. Okay, another way of accidentally writing C code is by importing C libraries, and that will probably come up in your project. Here, math.h is C standard library, which you can work in C++, because it's all interoperable. If you see a .h on a standard library, probably you can see, what you actually want is CMath. Do not ask me why they named it that. It's very confusing. It is ironic, CMath is the C++ one, but that's what you want to import. And the reason you want to use the C++ version is because here, C's power function only works on doubles. So if you pass a float to it, first it'll be converted to a double, and then back to a float afterwards, right? It's just not going to be as fast. It's just a bad way of doing things. STD PAL will automatically choose the right type of value then. Okay. The time someone came up with a new innovation, like rubber tires, they just added it onto the car. And the car got better and better, and all the innovations of the intervening 100 years have accumulated. And now picture what that car would look like. Do you have it in your head? Picturing it? Okay. So these are the ways of constructing objects in C++. There's a lot of different options. Here, these all do the same thing. Actually, before I do that, can anyone point out which one of these is a bad idea? One of these is different from the others. We can spot the difference. The last one is pretty reasonable. So that one we'll call the copy constructor. So this one makes a copy. This one sets the value. This one sets the default value of 0. But one of these is different. Yes?